of in Internet of Things. So please, okay, I will also here I will use Arabic and English language. So I will change to Arabic to talk with our student. السلام عليكم طلاب. اليوم عندنا محاضرة حول الانترنت اوف ثينكس. هاي المحاضرة سوف يلقيها البروفيسور محسن خاكاني من جامعة الفردوس في إيران. طبعا البروفيسور عنده مجموعة من البيبرات المنشورة، يمكنكم يعني مشاهدتها من خلال الجوجل سكولر. يعني عنده نشر حتى في سنة 21 وعنده سايتيشن عالي. في البداية حطوا عندكم تسوون ريز هاند كترحيب بالاستاذ. So student raise hand as expression of our welcoming to Professor Mohsen. Thank you.
Yeah. Assalamu alaikum wa rahmatullah. Good morning, everyone. It's my pleasure to be here and presenting this lecture for you all on the Internet of Things and Smart Cities. Let's introduce myself. I am a professor of computer engineering and head of web technology lab. And also I have been CIO and ICT director of Ferdowsi University of Mashhad for 18 years. I have actually, I was involved in many smart city related projects, including developing roadmap for city of Mashhad and city of Bushehr. And many other activities. And also I'm teaching the subject of Internet of Things for bachelor students in Ferdowsi University of Mashhad. This semester we also had it nearly finished. In terms of research interest, I'm actually a data scientist in the everything related to providing meaning to data from data mining, process mining, and those sort of activity as semantic web, natural language processing and understanding, social network analysis, and of course application of information technology. And I've been advisor to many companies national-wide and also many national-wide committee on the computer engineering related topics. Today I'll actually provide a brief introduction to Internet of Things, IoT, and smart cities. It's a general topic. I try not to go into much deep so that everybody can understand it, and usually provided an umbrella of the whole topics about this issue. Okay, let's start. So Internet of Things, word start with Internet, just a brief introduction. You know everything about the Internet. You are in the Internet and you know that when it started many years ago, it was slow, and suddenly with the invention of web in 1993 or so, everything was revolutionized. Actually, after the telecommunication privatization in 1995, internet and web exploded actually. And if you look at everything before this 1996, you see, I mean, a very slow increase in the usage and the users and everything. And if you look at the internet now, it's 1.3 million people, billion people, actually every 60 seconds, 1.3 million people logging into Facebook. 19 million texts and everything. So yes, I mean, it's amazing how it goes. Every minute, nearly
Sorry,
200,000 of tweets.
sorry,
So
Doctor.
it's,
The presentation is still at the first web first page. It's not like it's going to second page.
but it
Sorry.
is going on for me. I don't know what's.
Okay. Can you make a full screen
It
share?
says, okay, let me change it maybe. I'll share it. Is that okay now? Is that
Yeah.
okay?
Yeah, yeah. It's okay now. Yeah.
Okay. So as you see, everything has changed a lot. So the thing is, new topics actually have evolved during this period of time. So let's move on from the internet world to the things world. We have embedded systems. Embedded systems are any device, electronic device that has a computer inside. Any computer which is not a common computer, a laptop or something like that. No, anything that's has special usage, like think in car and everything that has a microprocessor in camera, even in your washing machine and everything else. And there are billions of them generated, and every year, and usually there are tens of them in any home and in your hands, your mobile, everything. So even maybe some even more personal things. So we have these embedded things, systems that we call them things. And as I said, there are a lot of embedded system. Sometimes in a very luxury and sophisticated car, maybe 200 of those microcomputer chips that are inside that car. And there is actually most, even the simple electrical devices now have a sort of embedded system. And you see that there are lots of things that you see on this picture, that these are embedded systems. So let's look at the way that networking is going. If do you see the movement of mouse on the screen as well?
It's clear now. Yeah.
No, yeah, okay. See, initially, let's go from in the X direction, the place connection. Initially, when you wanted to connect to network, you had to be sitting behind your PC and connected to the network from that PC. Later on, you could still use, for example, laptop, but somewhere connected to the network inside your home. It's not a long time since then, maybe 10 years ago or so, we were using the network like that. And then it came that in outdoors, there were some places that you could use that. And eventually it came that you can use it outdoor, indoor, and whenever you are on the move. So this place connection has become any place. The other dimension, let's go to the Y dimension. Initially, when I was a PhD student, when at the day when we were going to the university, we could have internet. during daytime. And then later on, even when we could come to home, we could somehow connect to the internet at night also. And then suddenly, I mean, anywhere, anytime you want it, even when you are on the move. So this time dimension also has changed a lot. And now we are talking about the other dimension, which is things. So whenever initially the networking was between PCs, and then it comes between the human and humans, like for example, you had your mobile phone, and another person had a mobile phone, and you could communicate using, for example, social networks. Later on, it came to this, you could communicate even with some things, like for example, however you wanted to use your mobile, for example, to turn on lights on your home, or to talk to your car and whatever. The last thing that is happening is that the things are networking and connecting to other things. Okay, so for example, your car is communicating with another car, with the road and with everything. So thing to thing, or connection, or anything connection has become a reality. So this, you see the kind of connection that people to think and see that, for example, there might be some ECG sensor for your heart. There are some motion maybe in your feet, and also there are some motion in your wrist and everywhere. Usually they are connected to your mobile phone or something like that, and from there it goes to the internet, and when it's on the internet, you could connect to everywhere, everything. And this is what we call it thing-to-thing connection, that you see, it's a different kind of things are connected to the internet. And as you see, this is a police car, and this is another car, which there are lots of sensors, lots of things inside, embedded actually part inside this car, and using a gateway or something, a connection like that. It, for example, maybe using 3G, 4G, 5G, or whatever, or Wi-Fi connection, you connect into the internet. So this is what's happening to thing-to-thing connection, and that is what we call it Internet of Things. That means the connection of embedded device into the internet. So whatever it is, either it's a CCTV, a smart TV, modern car, medical devices, and everything. So this is what we call Internet of Things, or IoT. Actually, this term was initially coined by some people at the MIT Auto ID Lab, and then the article that came is called it Internet Zero. Usually that initial connection was using the RFID or something like that, and this is just it was just a start. And the vision and growth of Internet of Things actually is a lot. So you see, actually, this is a sort of a number of connected device. How rapidly actually it goes into that. As you see, for example, this part, which is the green part, is the part that actually growing, and it is related to non-cellular IoT. So the thing that's it's not only your mobile, it is everything else. And you see, for example, this PC, laptop, or mobile phone connection, everything, you know, see, and they are not growing that far. But the other connection, which are the things that connects a lot. So it initially the number of things weren't much, but somewhere in 2008, number of connected device became more than a number of people on the earth. This actually shows another kind of connection that came. We just before the internet, we had this human to human fixed mobile phone telephony, or at most it was SMS, and then it came the internet of content or web, which we could see. I mean, we could send email, we could browse web, and that was a kind of a connection, and it had that from here we have sort of smarter network. And then it came Web 2, so Internet of Services, a lot of productivity, e-commerce, everything is happening. So we have IT platform and services that enable this. And it came to the internet of people using social networks, different kind of connection like the one that we are now using. So it's a smartphone and smart application thing that happens. And now we are going into the Internet of Things, which is machine to machine, identification, tracking, monitoring, everything. And smart devices are coming. And the thing is, everything has to become much smarter in an ambient context, in a global context, everything, and using artificial intelligence, the thing that we get from the devices, and we process them, and they can be used for daily usage. This actually shows that another picture shows how rapidly Internet of Things grows, and this is actually a broad picture that different service sectors like building, energy, consumer homes, healthcare, industrial, transportation, retail, security, networking, and everything, and the type of applications and location that you can use, and devices that you can use. This is actually a big spectrum that somehow is shown in this picture. And the trend of technology actually has come from, if you start from the 2000, that only using RFID tags for facilitate routing of devices, supply chain, sort of things. And then it comes to the thing that in vertical market, large surveillance, security, different kind of devices. Positioning becomes a very important thing. When we had really access, everybody had access to GPS, and other positioning sectors becomes that location of people and every object becomes transparent, and everybody had access. And then everything, the sort of cyber space becomes where that the physical world actually is somehow connected to the cyber, and we have teleoperation, telepresence, and ability to monitor, control the distance objects, and it's going on and on. See, also it shows that how smart home devices usually stays by category, and the market actually that's more than $2 trillion in this market. So it's becoming really important. So what has caused this rapid growth? What are the enablers? What are the drivers? The first thing is portability. You know, I remember when I was using this sort of mini computer or even larger mainframes when I was doing my bachelor, some I would say 35 years ago or so, 40 years ago. The hardware became really, the size of hardware were huge. Now it has become very small, and they are, the more important thing, that they are portable. And everything has been miniaturized, becomes so small that chips, everything becomes so small that allows you to have very, very small devices, very, very small micro computer-based chips inside anything. And some of them are really, really, small things. The other important thing that has enabled this growth is low power consumption and low heat generation. The new architecture of the chips allow that low power to be consumed by chips. So with very small battery, you can maybe survive for years. They can go into sleep modes when they don't have anything to do, and the battery lasts really for ages. And also they may also get energy from different things, like from light and other things, from the solar cell and everything. So the problem of the power has gone. And the connectivity. I think it's still, even you remember the time that the connectivity were really slow and really, and it wasn't as we needed. And now everybody has a Bluetooth enabled device on mobile, and Wi-Fi is usually everywhere. At this 4G, LTE is everywhere, and 5G actually is coming into the mainstreams. So connectivity is really what we do have now everywhere. And the convergence, you have a mobile, and all type of actually sensors everywhere. They are there. All application. Remember that, for example, even 15 years ago, if you wanted to have, for example, GPS, you had to have a special GPS device. You had a camera, either digital or analog camera, and your phone also could only be used for calling someone and text. That's it. If you wanted to play, you had to have a new game device, and now everything has been converged. And actually, the thing is, the other side is divergence. Is that there are different type of application and then different type of thing that you might even imagine that they are there. And the more important things is actually ecosystem, as ecosystem has been built. By ecosystem, I mean everything, the digital ecosystem, that everything that you do need to be able to use those small devices and those connectivity around us to be able to use them in different application. If that ecosystem doesn't actually form, you cannot have access to all of the things that we do have. And even see, maybe in my country, in your country, we don't see some of the application of the new technology because the ecosystem hasn't been really formed in that society. As an example of that is a smartphone, that everything that we said actually is there, and even in the ecosystem, see the cloud, social network, software development kits, application store, everything, big data is standard, everything has been formed, and now your smartphone actually as everything. You take your smartphone and you go to a really remote area. It's useless. I remember that there was actually a part of movie from, I think, Charlie Chaplin's movies that shows a man is coming, actually I think it was a lady coming into the scene and going out, and it has something, her hand was near her ear, and as though that she was talking with a mobile device. And everybody said that, oh, okay, that's a man from the future that has come. And the people start thinking, what are you talking about? I mean, just having a smart or a mobile phone does not solve anything. A lot of infrastructure should be there that you can use this, and that's actually the main thing about ecosystem. So if ecosystem is not there, you can't get the most benefit that you could from the technology. That's what I'll go into much detail when we talk about the smart city. So there are lots of sensory equipment from the medical part, or from the thing that you have at your home. This sensory equipment actually sense the environment, convert the analog signals, whether it's the humidity, temperature, or whatever it is, into a sort of digital form, and then you can measure it, and you can sense it, and you can decide based on those measurements. So in terms of elements of IoT, of course, we should have those things that we have about the information technology, everything that we had, the networking, computers, everything, and operational technology. As I talked, that's the thing that how things are operated in the real world, and smart objects. So if we have all of them together, we can use the IoT actually in the best way. In terms of platform, actually, see, if we consider user an environment that's on the upper side of this figure, we have some device layer which actually resides in users' environments. So there are sensors that sense the environment, and actuator that actually do and apply the commands, and they are everything about things that we call them things. And that thing has a gateway that does the communication with the network, and with the network, and that networking actually connects to the internet, and the servers everywhere are on the internet. So this part, the lower part, is the networking level, which everything decides. So maybe you have very small things, sensors at the top, and then all of them connect to, for example, maybe your gateway, that might be your mobile or small device that's at the corner of your home, a modem or something like that, that connect to internet, which servers are there, and actually they do the actual jobs. In terms of communication technologies, the connection to the infrastructure network that I showed the previous slide, usually wired, either most of them actually fiber optic. Some of them may be actually even using the satellite, but mostly they are fiber optic based. But connection of the devices to the gateway, and usually is using different types of wireless technology. And the most important thing is that one of the main enablers of this technology in location-based services is that sensing and understanding your location, either in the open space, or in a closed space in your home, inside the building, and based on your location, they provide services to you. So they call it LBS, or location-based services. In terms of wireless, there are lots of actually technologies and everything. New one actually comes, like Bluetooth, Zigbee for connecting very small devices, Wi-Fi that you all of you are familiar with that, radio frequency RF. I think that connects in the different modes, cellular, or that mobile phone, and DSRC that usually used for connecting cars in this sort of, for example, the wireless technology. And as I said, in the location-based services, in the open areas, using GPS, the most important bad thing about GPS is that battery usage is a lot. So even if you use GPS on your mobile, your battery drains so quickly. In terms of inside building or closed spaces, many actually technologies can be used, from RFID for tagging, active RFID, passive RFIDs, or Wi-Fi for location tracking. You can use Wi-Fi for tracking location in closed space, and also you can use Bluetooth, for example, like iBeacon or things like that, that when you walk, for example, inside a really big shopping center, using blue beacons or something like that, your location can be accurately determined, and appropriate services based on location provided to you. The thing is actually the life cycle for this thing is at the stage one, we collect the data collection, is using the context of the location, time, ID, whoever uses it, where it uses, and when it uses, and using different type of validation and verification sort of thing in that data collection. And then it has to go through data analytics. The computer server, everything, aggregate everything, correlate them, benchmark them, profile, and then we could get to some sort of decision. And the stage 3 is that from those sort of analysis, and the use of data, we could understand how we can use those sort of data that has been gathered to provide a better services, so that everybody can understand it easily. For example, you go to near your house, as soon as you become behind your door, your face is recognized, analyzed, and then based on that decide, okay, this person has access, and then we can open the door for it. And different type of visualization of the action that you have done. Some of them when you see in your mobiles that shows how, for example, you have traveled this using, for example, Google Map this week or in this area, and you could easily see that, okay, if I want to go and discover new things in my environment, these are the places that I've been before, and then new things. This actually for fun, and there are many things that can happen there. And of course, the application that has come from media, environment monitoring, infrastructure, manufacturing, and I'll go to some of some details of that, and most actually are going to the smart city after that. Actually, if we want to categorize them. We might say that Internet of Things as provided thing that augment the existing things. Means that we had watch and then we have a smartwatch. It not only shows us the clock, also it can be count the number of steps that you have taken. You also maybe get some health parameters, collect them from you, and many other things actually, or provide services for you. You can get your SMS or social network messaging, everything, and even it can take photos, everything. For example, you had this, and then this comes something like that. That's provide much more services, and you have that electricity outlet, and then you have the most smarter one that you can, for example, program it to turn on or on a specific amount whenever you like, and turn off, and actually you can also measure the amount of electricity that the device uses and everything else. So it's a different kind of metering. Or you could have just these glasses, and then you could have things that not only helps you in seeing better, also provide a lot of information like Google Glasses to you as soon as you look at somewhere. For example, a name of a restaurant, it provides feedback, how good it is, what sort of foods it provides, and how is the rating, how is the pricing, and everything else. And of course, the thing is augmented life with new things, smart city, smart cars that drive by itself, and smart me in terms of fitness, wellness, healthcare, and everything. Smart driving actually said that more than 150 million cars. This is a prediction, and somehow it has reached to that amount. Connected roadworks. I see that there are lots of accident, everything that's happening. This is actually a number of things in 2012. There are a number of crashes and accidents, and so do emissions. And if we somehow optimize the way that it used to be, we can actually have better life. Like for example, this smart car, that there are lots of sensors, radar sensors in front, in the back, and the GPS provides an ultrasonic, for example, sound showing the objects that are very close to the vehicles, and there is a central computer that actually collects and aggregates everything and send everything to the service provider. And there are lots of things that's happening and you see there are cars that they actually self-driving, and actually this figure shows you that everything actually sending signals and detecting signals, and based on that decide that okay, a person is walking through the stop and the red light, everything actually, not only they show the light, actually they send the required information so that the car realize, okay, this is a green light or something like that. And the connected factory, that's everything that is happening there. In the new factory, actually, you can change the production line easily with just a few maybe sometimes commands, and everything changes the way that robots here are doing, and in terms of logistics, that sends everything, and even in terms of risk, you always have control about the company, and then because you have data about everything, you can do a lot of actually innovation and efficiently manage this factory. New products, that's productivity and the workers, and of course cyber threats, and I'll talk a little bit more about that. Smart buildings in terms of energy management, lighting, safety, HVACs, automation of home, smart spaces in terms of parking and everything that are provided. So that's a smart building forecast is reaches to something $25 billion. I was checking last night; it's actually nearly above $40 billion by now. And the thing that you might not actually imagine, it's a smart creature. So different type of sensor, for example, some sensor in the necklace that in Dutch company actually in Netherlands has provided this that monitors cause movement and feeding habits. And there is also a pedometer that measures how far it actually walks. And there are some things that monitor the acidity inside the stomach of the cow, and there are a lot actually other sensors. And one of the interesting thing is that the tail movements that the Irish company has did that whenever a cow wants to give birth, actually there are a lot of movement in the tail. So when it detects, it realizes that laboring is near and the contraction has started, and they actually send SMS to the nearby vet to go and do that. And I think actually said that becomes a sort of co-group that IoT enabled that can go everywhere and does a lot of monitoring things for you. Smart grid, actually now in terms of electricity, they want to not only actually connect all of the power plants that are there or water plant, but also there are many solar panels that every house has, and they whenever they need it, they use that power that, for example, provided by sun or by wind or whatever. And when they don't need it, they actually send it and they get paid for the electricity that they generate. So we can sort of do demand management and provide everything. This is also one of the things that's in a smart city. Usually there should be a smart grid that green electricity can be provided to everywhere. And a smart home that there are lots of sensors, security camera, TV speakers, locks in the door, even the irrigation of the agricultural and the plants that are there, controlling appliances, lighting everywhere. And actually the thing that people actually decide is the smart lighting that a company actually Philips provided, and it activated by your smartphone or using, for example, Zigbee wireless, and you put everywhere this sort of lighting, and they can actually even act as an alarm clock. When you set it at the time, just start flashing, or even you can synchronize the colors for the for music that is playing. So the lighting also goes as the sound also goes, and actually it's just in 3 months everything was so loud. And the smart health that now all of us actually may be using this sort of technology to see how far we walk, how is the blood pressure and your heart and everything. And the smart city that I'll talk about that more in terms of parking, lightings, cyber services and traffic signals and everything. and many other smart things that you see. I mean, also there are these small toilets that even check that there is problem with you in terms of your stomach. Smart refrigerators that has come out. Smart history in the museum, you go and walk, and as soon as you get near actually a sort of art, it's got lots of information history about that. A retail shop and everywhere. Okay, I'll go actually a little bit more detail of IoT and its application in the smart cities, and see if we define what is the smart city and what IoT actually has provided the infrastructure for this smart city. What is actually a smart city? So these are actually some of the definitions. That says when digital technology is interweaved into all of its activities, or a city that use ICT for not only its critical infrastructure controlling, but also the connection of all of the components to each other, so that more interactively, more efficiently, and making the citizen more aware of the environment and everything. There is actually no single accepted definition for a smart city, but most of them actually goes about the things that digital client, digital community, digital citizens, and sustainability, and everything actually is that using technology to improve city and services. As you see, the governing a city electronically, what we call it government, is that if you can control the different level of everything using the ICT technology, and deliver wide range of things to the wide range of citizens. So this is actually a sense that a stage of development of the e-government is starting from some initiation. This actually is a picture from 2005, shows how that e-government should actually go. So it starts from initiation, contingent, control, interoperability, and then and the thing is, at the end is citizen participation. After that maturity, every citizen, and actually in a smart city, we have smart people, smart citizens. So this is actually a sort of network society. You see everything from that: commerce, security, education, healthcare, transportation, utilities, and people interacting with each other. And there is integrity of everything, and the trust, the competence, innovation, everything is inside of that city, networked the whole society together. Actually, the new word has come in these recent years, that's just smart, sustainable city. That's whatever you have in a smart city, you provide all of the services that improve quality of life, a better urban operation, while ensuring that it meets the needs of present and future generations. So sustainability is actually one of the main issues, and now it's one of the main drivers for becoming deciding to make a city smart, so that you have control about every part of environment. What are the characteristics of that smart city? It's a city that use ICT for using physical infrastructure, better usage, roads, building, everything. And this is learn, adapt, and innovate in responding to change in the circumstances and environments. Condition changes, whether it's traffic, whether it's the parking place, everything. It's actually learn that how to provide services. For example, if the middle of the center of the city becomes so crowded and there are lots of traffic and car there, it actually decides how the green light should activate so that the traffic reduces. And also the thing is, because of that environment, people can interact much better with the governors. And we have a digital participation and digital co-design. So we together they design the environment. And make use of the actually different type of industries that in this sort of social network connector, we have volunteer organization, and this actually shows that a smart city provides a lot of facilities so that we have a sustainable city. And of course, there are lots of motivations as the population grows and change in the age pyramid because of the better health. So there are lots of people that with the age above maybe 60, 70, and they need a lot of help so that maybe we have to provide the environment that while they are sitting in their homes, we provide services to them. And the changing environments, and the thing is, the economic growth has become polarized. Meaning, in some sectors, some society performs better. So, if we have a smart city, we can provide services to them while they are sitting there and doing their activity there. They can sell and they can actually provide other sort of commerce with each other. If you look at the standard actually documents, you see lots of dimensions for the smart city, starting from smart economy, smart mobility or transportation, smart environment, smart governance, smart living, and of course the smart people. Let I quickly go through some of these. In terms of smart economy, the thing is, in a smart city, we should provide the business climate, the overall business climate, so that for startup investors, it becomes more attractive, so that new talent and high qualified talent person can use this and actually grow the economy. So the thing is, everything goes at using this the technology for economic prosperity, or smart economic development, which is a tool for actively seize opportunities and provide condition for everyone to use new jobs. Smart mobility mostly means that transportation, urban transportation. Now, if you go to many actually modern countries, maybe even some even here in Mashhad, or I don't know, maybe in Basrah or somewhere, you see as usually people just using a car can travel everywhere, and data are collected actually in terms of payment, everything. So you can have a cheaper, faster, environmentally friendly mobility through different types of transportation services. And the thing is, this becomes this mobility is customer centric, which is one of the important things. And in a smart environment, A smart environment means that that natural environment has to be protected and managed so that uh, livability for citizens and visitors improves. For example, the reduction of waste production. You see, actually, for example, in many countries, the bins, the waste bins, they have been designed that actually not only, for example, in Australia, I've seen that some of the bins that can collect 10 times more waste by compressing them as soon as you put something inside them, and actually inform the people who are collecting the waste whenever it becomes full. You know, one of the big actually amount of the cost is the collection of the waste. So sometimes you go that the bins are maybe half full, and you could, for example, instead of twice a day, you could come once a day, and that means a lot in terms of saving. And of course, a smart environment that use crowdsourcing, co-creation, and the concept of city as a service. There isn't enough time for me to go into that detail. Just a brief introduction into that, and everything goes to smart living. That quality of life increases, and social and digital inclusion means your interaction with the whole world uh, in this smart living uh, becomes a reality. And of course, for smart city, we need smart people, smart citizens. So we have to actually transform the way citizens interact with the environment, with the government, and everything. Uh, how? Via the provision of the information and services to them, and provide a sort of education to them, so that they actually the environment becomes participatory, the open-mindedness and creativity, everything becomes uh, available for people, and we have smart citizens. The infrastructure of that city starts from that sensor network, that's IoT, the networking infrastructure, processing center, software services, and content that are quickly go through each of them. The most important actually part is that in a smart city is the sensory network that provides data for the other layers decision. So in terms of, it says, urban management, traffic management, lighting, air pollution monitoring, smart parking, leakage detection for water pipes, everything, and even some military, health, environment, and digital life. So this sensory network that should be everywhere in the city is the main part, and sometimes the most difficult part to, in terms of physical part, to provide. And then all of those sensors have to be, you should have a good networking infrastructure. That's everything from local, urban, wide internet to be connected together through internet, and through different type of media, copper, optical, wireless, so we can have access to data that has been collected by the sensors. And those should go to a processing, a cloud-based center, process them, and provide services based on whatever data that it has provided, and then sends commands so that something happens, traffic lights becomes green, becomes red, and somebody should go and collect waste bill and everything. And the services, different type of services, portal-based, smart card-based, public network services, and everything, software services is built on top of that cloud or processing center, And of course, the main important thing that the content and the usage that some people or some organization should provide content and some should come and use them. So needs for participation of everybody in the city, those smart citizens, which is the somehow most difficult part and the time consuming. See, I'll just provide an example here, like e-learning. We, for example, I think maybe nearly 20 years ago, I provided the e-learning infrastructure, I mean LMS and everything within the university. But and even for more than 10 years, we even has courses. We had courses that it's totally electronic based. But before the COVID disease, little part of that infrastructure had been using. So now that whatever has happened, people are using, and e-learning has become really a reality. This sort of thing that requires, I mean, a lot of cultural building to happen. And this figure actually shows that the relation between the IoT, that any services, any path, anyone, anything, any place, any time, provide services for those smart city, that smart living, smart mobility, government, and everything happens. So IoT provides that smart city. It needs this IoT technology to provide those services. This actually shows another way that the infrastructure thing that we see a lot of enabling technology like sensors, blockchain, data visualization, crowdsourcing, big data analytics, actuators, Internet of Things. To be used in the transportation, energy, solid waste management, water management, geotechnical system, and everything, air quality to be used. This sort of, for example, sensor that in a smart infrastructure application can be used in terms of temperature, pressure, flow, water quality. See the different type of sensor, air quality, digital imaging, positioning, humidity, energy, strain gauge, navigation, radiation, and do a lot of things that some of them actually used in all domains like temperatures, some of them may be used in water management, and there are lots of actually sensing and site that can be used. I didn't talk much, I just mentioned something about big data analytics. All of those sensors are generating data each second or a part of seconds, and consistently generate those huge amount of data, different type of data, and a different speed and a huge. And I think we need a special type of analytics to be able to explore this data, visualize them, analyze them, visualize them, to get the knowledge out of that. If you want to make use of that. And it requires actually a special computing, storage, and techniques. So big data has a really important role in a smart city application. And of course, artificial AI techniques should be actually enhanced so that they can work on big data as well. If we can develop good algorithms that can manage big data in a good amount of time, it can make a huge difference in our life. But everything comes at a price, and there are lots of challenges actually, and some of them are really difficult to manage. There are some technical challenges, start from security and privacy, that I talk a little bit in the next slide. And there are also in connectivity. There are many different networking protocols. And if you want to provide the connectivity, you have to make sure all of them can talk to each other. And from the technical point of view, it is really difficult. Because the thing, each company produces a device with support some kind of tech, even with this similar protocol in terms of names, somehow there are differences in terms of actually usage, and they don't actually sometimes cooperate with each other. So compatibility and longevity. If we have sensors everywhere, so most of them use wireless technology, and they are everywhere. So if they actually say the energy consumption is a lot, or even it's not a lot, actually sometimes maybe a year or 2 years, you have to replace them. Replace either batteries, usually replace the whole sensors. If the battery drains and becomes flat, the sensor doesn't work. That thing is dead. So in the long run, it's difficult to actually provide those sort of, and the new devices has to become connected, trusted, and used in the way that the previous device was using. And the thing, after a few years, some devices may just become faulty, and you go to the store, as you go, for example, for auditing assist, there is no similar or the same sort of technology there. And you have to use a different device. And the thing is, they might not talk with the other devices. So it's a really a big challenge. I'll talk about security and privacy in the next slide. The thing is, if everything is connected, so there might be attack everywhere. So from the pacemaker, which is on your heart, it can be attacked. The simplest attack is what they call battery drainage attack. So in terms of, somebody comes near you, so sends commands that the processor inside that pacemaker works harder, and instead of a battery working for many years, after a few weeks, your battery becomes flat. So you have to do another operation, changing battery or lots of things. And in terms of personal fitness, your watch says that you are running and you are everywhere. And if somebody can steal information, they know that exactly where you are, and they want to steal something from your house, they know where you are. In terms of car, for example, they take control of car. For example, you just open the lock by hacking your system. Your infotainment means that sort of LCD device which not only shows you some information about your car, but also you can connect with your Bluetooth, and for example, you send a music and a thing, or your calls that comes, you can use the microphone inside the car and everything. So how about hacking through the Bluetooth into that and sending commands, disrupt services into your car? It has been shown actually in a conference about 2 years ago, that how a car, a smart car, I think it was a Jeep Cherokee, can be hacked, and when you're walking into you're actually using the car inside the highway, something happened, even the brakes might break, and nothing should work. And now that even that there are self-driving cars, and a lot of things can happen. There are risks everywhere. In video cameras, you put video camera to control your home. Somebody else also can see whatever inside that. But we have shown actually that most of them actually are at risk. Cars, I talked about industry. And a lot of things happens today in some industry for political or competitive, commercial competitiveness, and they just hack an industry, like for example, as you see this in petrochemical sort of things in the region, and suddenly you see your factory doesn't work. The most important thing is they are really difficult to prove. In retail, so a lot of things has happened actually from stealing the credit cards and stealing a lot of things from the point of sale devices in retail shop. And there are lots of hacks that happens. Air travel, medical devices, as you know, at the moment in most modern hospitals, everything is connected. Imaging systems, packs, everything, and they are connected. And if somebody can access to that network, they can get everything. And you see that sometimes, as shown, that health-related information are even actually worth more than credit card information. Since a lot of politicians, if everything about their health actually appears, nobody vote for them, says, hey, this person is going to die in 5 years. And in terms of cities, buildings, power grids, so as I think you have heard that even in US, a few weeks ago, some hackers actually for just for the commercial, they could hack the gas pipeline systems, and they could using some cryptoware to encrypt everywhere. And I think they got $5 million to open it, to decrypt it, and cyber warfare, everything else. So there are lots of things there. So in general, if you talk about the IoT advantages, it of course provides a lot of good thing for data collection. Then you can, if you have data, you can do everything. And customer interaction, reducing waste, and optimization of the technology. But there are some disadvantages as well. I mean, in terms of flexibility, you might provide that it provides flexibility, but as I thought, because all devices should integrate together, so sometimes you have to go for a special brand or special type. Otherwise, you can't have that sort of advantages. Security and privacy that I talked about, I mean, there are a lot of actually concern about security and privacy, and stealing sensitive personal information, and actually hacking into your home and your city causes a lot of problems. See, for example, in was it I forgotten the year that there was a problem with the Russia and Georgia, and they hacked the ATM device. Nobody could get cash. Actually, it didn't work. So I assume that at the moment, for example, gas station, Uh, if somebody hacks and you can't access the gas, what happens in your city? And of course, the complexity is a lot. I mean, you need really expert engineers to design, maintain, and exploit the manifold technology. Really, I mean, it's huge amount of technology in terms of ecosystem is there, and managing them is really difficult. There is no way you can avoid those IoT growth and vision and a smart city. You can prevent it, but you should look at these sort of problems that are there and prepare for that. And that's the end of my talk. I hope that I could provide some general background information for you. And if there is any question that I can answer, I'm at your service.
Thank you very much, Prof. Thank you for this information that cover different area in our life and how can the Internet of Things improve our life and using the resources. Thank you very much. Now will we open the question to our students. طلاب إذا أكو واحد عنده أي سؤال للأستاذ بما يخص المحاضرة اليوم، كان يمكن سؤال بالعربي أو بالإنجليزي، إحنا نقدر نترجم إياه. راح نشجعكم على السؤال. هاي فرصة لكم للمشاركة والتفاعل مع المحاضرة، خاصة المحاضرة باللغة الإنجليزية كاملة كانت. حيدر صباح، لك سؤال؟
السلام عليكم.
Welcome to us, Professor. At a present day or a future, can a person or a humans consider as a thing? Can that be analyzed and sent it over internet?
You said that whether in the future humans are considered as things. Humans are not considered as things. What different part of thing are connected to them? So you see your watch, and the thing is, all of them actually maybe without your knowledge actually talk to each other. You see, sometimes I remember there is a ayah says, اليوم نختم على أفواههم وتكلمنا أيديهم وتشهد أرجلهم بما كانوا يكسبون. So everybody who says, police takes you, your car says, you speeding. It says, I didn't speed. No. The police said, no, your car sending your exact speed to us. So you can't say, no, I wasn't speeding. You see, if I did understand your question well and answer that. So everything that is connected actually, when actually connected to you, speaks and interact with other devices.
Thank you.
Thank you. Is there any question? Actually, I have just one question. That according to that you mentioned at the end of the seminar, that one about the challenges and also about disadvantage is about the security and flexibility and compatibility. So is there one standard about IoT so that can be different sensor that belong to different manufacturer can be sent information in one format and can be used and can be take action? Is there like standard for that, and also standard that can be used to restrict the using the information in this about the security issue?
Actually, there are standards, but the problem is one of the problem about the the IoT security. I've given many lecture just on the IoT security, and actually this week class will be about that IoT security. The last week, the thing is, the condition that the IoT devices are generated, making them really vulnerable to the attacks, because actually they are generated in really distributed environment. Everybody making a device and try to make it as cheap as possible, and try to make it as small as possible. So very small amount of small actually processor are there. They cannot handle big encryptions. They cannot handle big security standards and handle them. And the thing is, they usually they are built in mostly startup companies. They don't have enough knowledge, enough devices and things to make them really secure. So it's really big issue, really big issue. And actually it hinders many development. So sometimes it says, when you design, you should design with security in mind. So, and it's really sometimes difficult, really difficult. So to answer your question, yes, there are standards, but the problem is the ecosystem of the security standard is not complete and pervasive enough to prevent us.
Thank you very much. Thank you. طلاب اكو واحد عنده بعد سؤال؟ Student, is there any question? Yes, لواء.
Hello, Professor. First of all, I want to say that we are really happy to join this amazing meeting with you, and to share with us all that knowledge about technology and how it's being mobilized in this area exactly. I have some concern, if you want to say, like some questioning. With all this advanced technology and softwares around the world, like, you know, Linux, Kali, or etc., a lot of operating system that's based on and architecture on hacking. You know, the hackers around the world use these systems and softwares to hack and to breach a lot of companies, a lot of sites, a lot of banks, etc. What is the chance that people in the future, with all of this technology and softwares, that we will be able to seize the hacking, seize the breaching with all of this advanced technology? And thank you.
Actually, there is no way. I always says that thieves are one step behind, ahead of police. So it is really impossible. But the thing is, it is inevitable. You cannot not use this technology. But you maybe, the thing is, as we say, you should provide multi-level of security or deep layer security. So if one layer is breached, the next layer. So for example, in terms of your home, maybe you have some big door and locks, and then you have the security camera, and then you also lock the inside of each room door, and also maybe you have some boxes, special boxes with the special locks. You put the more valuable thing inside them. Actually, as I said, for the IoT, the security and privacy actually concern are really a lot. It's really difficult to manage it, you know. But it's not time that is I talk about it, because I said it requires just another lecture to talk about it. Some of the issue even in this area. So it's really a challenge, and it hinders the development. And actually, when there was a survey asking people that what are hindering the usage of IoT in the industry and the smart city and everything, and the most people said the security is the main concern. It is really important. But the thing is, we have to, and we have to educate ourselves so that it doesn't harm us. See, because companies, they want their money, and they want life be easy for them. For example, more than 90% of POS devices, point of sale devices, that are installed in everywhere, actually. Not only I'm talking about in Iran or in Iraq, I don't know anything about Iraq. They have very easy passwords. Look at even your modems. The password sometimes is admin 123446 or something like that. And middleware, they should be upgraded constantly. Like for example, I had a ADSL modem and it's been there for maybe 15 years. The company doesn't provide patch for the new security. So what I should do? I either should accept the risk and say, okay, or I have to buy a new one. Because that's it. I mean, if somebody attacks, and you know it has happened, it's not time for that, that they hacked the modems and they stole the millions of credit cards. Because you know, you collect everything. At the moment, fortunately, the communication usually are encrypted, but it wasn't before. And they could easily actually steal the credit card information. So it's really a big concern. I'm trying to educate people. I'm educate government in different points. And actually, I for many years, I think maybe the first 7 years ago that I gave a lecture on IoT security concern on a conference. That we should look at it more carefully. But do you think has happened?
Thank you, Rob. Thank you very much about this information. Thank you. طلاب اكو بعد واحد عنده سؤال؟ Student, if you have any question more. Okay. Would like thank you again, bro, for this information, and we hope more cooperation in the future. Thank you very much. Thank you.
Thank you for all of you for listening. Assalamu alaikum wa rahmatullah.
وعليكم السلام. شكرا طلابنا الاعزاء حول هذه حضوركم لهذا المحاضره. اتمنى لكم الاستفاده من هذه المحاضره. شكرا جزيلا لكم. يعني تقدرون المغادره. شكرا جزيلا.